Okay, so I'm Nick. This
I'm
is Nigel. Today we're going to talk about AMP, Accelerated Mobile Pages, and does it make your site faster? We do have some slides that you guys can follow along with if you want. I just tweeted out the link as well, so you could go to my Twitter to get the link, and we'll have links at the end as well. So Pat suggested we just say yes, and that's it. So we can all get drinks, right? Okay. Just kidding. I'm going to hand it over to Nigel to get started.
Thank you. So first of all, what is AMP? AMP stands for Accelerated Mobile Pages. It's a perfect title. It's exactly what they're trying to achieve. They want to build a better way to build websites to optimize performance. There are three major components to AMP. The first is the AMP HTML. It's similar to HTML5 with some restrictions. There's also additional tags. There's the AMP JavaScript, which is the what makes everything work, and it's what you include in the site. There's the AMP Google Cache, which is a CDN that's free of charge, and it's used for all AMP content. So what can you include on an AMP site? Well, you can pretty much make an AMP site look exactly like you would a regular mobile site. You can include text, custom fonts, images, videos, advertising, third-party embeds like YouTube, Instagram, tweets, and there's a lot more. What you can't include, these are some of the restrictions. You cannot link to external CSS. You cannot use custom JavaScript with AMP, either inline in the page or referenced externally. There's an exception, which is in AMP iframes, and we'll get into that a little bit later. You cannot have Flash or Java applets, but no one cares anymore. And forms are still experimental and coming soon. So what could performance mean for mobile devices? Well, it could mean a lot of different things. We want faster load times. We want to use less bandwidth, less memory usage, less CPU, less battery. And overall, we want a better user experience. And these are all parts of the word performance. AMP enforces a lot of best practices to achieve this performance. JavaScript is all loaded asynchronously. The CSS is inline to avoid font downloads. The CSS has a size limit, it's 50K I think, and element dimensions are mandatory. This means that every image you have in your page or every video element you have in your page has a fixed size. And this is primarily because of DOM layouts are extremely CPU intensive and take a lot of time. And also it allows them to reserve space on the page where that if an image download is slow, there's less jank in the page because there's a box that's ready for it to be filled out. Resources have like a priority in loading where that things in the viewport are fetched first. Things that are outside of the viewport are lazily loaded. AMP is pre-render aware, and that when it's in pre-render mode, the things in the top of the viewport will be loaded and the things at the bottom won't be, and this saves resources on mobile devices. Again, with the caching CDN, we cache, AMP caches HTML, the JavaScript, images, and fonts, and the JavaScript resources used by AMP are shared against all of AMP pages, and this means that if any of your users have visited a different AMP page in the past few days and then are visiting your page, chances are the JavaScript is already in their browser cache, which is a huge benefit. AMP is also smart for business. Google is prioritizing AMP in search results in both native and web. I don't think they've actually told anyone that they're prioritizing it, but if you do a search on a mobile, chances are you'll have AMP results in the news carousel. There's support for ads. There's over 60 vendors, like Google AdWords and things like that. And there's the Google AMP Cache, which is free of charge, and it could really affect your IT budget. So for developers, why is AMP important? Well, AMP is actually very easy to learn. If you know HTML, learning AMP is just a matter of looking at the documentation for a few minutes. It's no surprise that there are a lot of WordPress sites out there, and having An AMP version of a WordPress site is easy. It's simply a matter of installing a plugin. There's a built-in validator in AMP, and it's easy to view and see the errors in your AMP page. Simply add hashtag developer equals 1 in your URL, look at your favorite dev tools, and look at the console logs for errors. There's also a really nice Chrome extension that does the same thing. The documentation in AMP is excellent, and there's a lot of examples for you to draw examples from. It's an open source project, so if you want to see how something works, simply just look at the code. If you have an issue with AMP, look in GitHub, open a pull request. Maybe it's been talked about before, and you can get help that way. Coming back to the CDN again, the CDN uses HTTPS. They use H2, quick and speedy. The backend servers that the publisher owns doesn't have to support those protocols. You just need HTTP or HTTPS, and you'll automatically take advantage of H2 or quick. There's a throttled cache revalidation, meaning that your servers don't have to be as strong as the AMP cache does. And the cache will actually serve a stale page to the user and then revalidate its cache in the background. The Google AMP cache also does image optimization. We've seen large images get scaled down to 1024 in width from like something massive, and obviously this saves a lot of bandwidth. They also they're also able to change the encoding and use WebP for browsers that support it. The fonts are cached also on the AMP CDN. There are 4 whitelisted font providers that you should choose from. The HTML served from the AMP CDN is also rewritten a little bit so that the fonts and the images are also served from the CDN. And they do some HTML validation, sanitation. It's not exactly minification, but they remove HTML comments and make sure that the DOM elements are properly closed. There's also AMP validation, and where that if the page is not valid AMP, it will not be cached by the AMP CDN and probably will never end up in Google search results.
Okay, so Nigel told us why AMP should be fast, right? But we should validate that. Trust but verify. How do we measure these AMP pages in the wild? There's a lot of ways to do this for traditional websites. You can do things like web server logs. That doesn't work with AMP because often the CDN is going to be serving the content, and Google's not going to give you the server logs for that. We would use something like navigation timing to look at the page load times, the DNS times, that kind of stuff with a regular website. But since we can't use JavaScript in AMP, we can't do that either. Nigel mentioned that you can have an iframe and have JavaScript running inside the iframe, but they're sandboxed. So your JavaScript in the iframe can't actually get the performance data of the main page. So we have to end up falling back to something like synthetic or RUM, and we're actually going to go into synthetic first. So synthetic monitoring is using something like web page tests, where you're in a controlled environment, you're loading things side by side or over time with one or a few number of devices, not looking at real world data, but like a controlled environments data. So let's take a look at some synthetic RUM monitoring, synthetic AMP pages. So in this case, we're actually going to take a look at BuzzFeed. They have both a desktop website and AMP versions of a lot of their articles. Here you can actually see an article on some Lego Batman cool stuff. You get to see a lot of the same content in both AMP pages and regular pages. The regular page on the left has a lot more navigation, sidebars. Below the fold, there's a lot of like related content links and that kind of stuff. On the right, you see AMP, and it's a lot more streamlined, right? There's actually a bigger image, but there's less navigation before and after the content, but it has all the same text, for example. So we can send both these pages to web page test. They're different URLs, so we can use something like one of the emulated devices or a real mobile device to actually do page loads of both these pages on a mobile device in web page test. And you can even see on the left right here, which is the regular site, the waterfall is huge. We're downloading a bunch of resources. It actually scrolls below the fold. Compare that to the waterfall on the right, which is really teeny, but that's good because that means not a lot of resources are being fetched. And you can see this play out in the actual data that you get. So the top is the regular website. We see that it loads in about 29 seconds, loading 5.9 megs worth of data. Compare that to the AMP version of the same page, which loads in about a tenth the time at 3 seconds, and is loading only less than a meg worth of data. So in this one example, we're seeing a web page that the AMP version is significantly better user experience for the visitor. You can see that in the first byte time, start render time, all that kind of stuff. But AMP pages don't necessarily guarantee performance. I'd just like to point to a counterexample of that. So again, we're using web page test. We're actually using another version or another page on the same site. And in fact, we're actually looking at, in this case, BuzzFeed has a mobile optimized website. So we're comparing the mobile optimized website to the AMP site specifically. They have about the same amount of resources in this case. The mobile optimized website on the left has a much smaller waterfall, much less resources are being fetched. And we're comparing it to the AMP page of the same version. The mobile optimized site loads in about 12 seconds, less than a half meg worth of data. But for some reason, the AMP page took 70 seconds to load, 6 megs worth of data. We looked into this a bit. It's actually because of an animated GIF. It's like surveillance footage, the long scene of surveillance footage. And for the mobile optimized website, BuzzFeed wasn't actually fetching this data until you hovered over it and scrolled it into view. However, on the AMP page, all the images were fetched immediately to try to render, to try to show right away. So it's actually trying to download this 6 meg animated GIF, whether the user cares about it or not, right away. And so you definitely need to test, right? AMP does not guarantee performance in any way. Test your real sites versus the other sites. Look into it, do deep dives into it. So synthetic monitoring can be good to look at your AMP pages to make sure they're working well. It's not the final say in everything. You're not getting real world data here. You're not getting real devices, or maybe you are getting real devices synthetic, but you're not getting the wide variety of devices that your customers would actually be loading data on. It's not real user monitoring. So how do we do real user monitoring?
So exactly, how do we do it? If we're not allowed JavaScript in AMP, how do we do it? Well, we're lucky it's built into AMP. And there are 3 ways to do this. The first is using an AMP pixel tag. And this is like a tracking pixel. You set up the tag with a source that points to a beacon server, and it uses it like a template system to use variable replacement to embed metrics into your query string. There's no extra extension download required for this. AMP pixel is built into the base of AMP. It's triggered during the page layout, but with a very low priority. But it's not tied into the onload event, so perf data that you're looking for might not be available at the time. Here's just a little example. So we're sending a beacon to myserver.com, and you can see that the variable replacement look a bit similar to like a bash environment variable. So here we're sending back the URL of the AMP page and its title back to our beacon server. So a bit more about this variable substitution. There's a lot of information you can gather from AMP, and it's all built in. So there's information about the document, like the URL, the refer, etc. Navigation timing API is fully supported. You can get info about DNS, TCP connection times. The navigation type is also supported. That is either like a normal navigation, or if the page was issued during a reload, or someone used the back button to navigate to it, and the number of redirects that happen before landing on the page. You can also get a persistent client ID, and we'll get into this next. And there's a total engaged time. This is like a kind of an estimate of how much the user is interacting with your page. If they're touching things, if they're moving around, this is considered engagement time. You can also get the screen and the viewport dimensions. And there's a lot more, and the documentation link is at the bottom. So about this client ID, in AMP we're not allowed to set cookies, and we're not allowed to set the plate in local storage. And the reason for this is because most of the content is served from the same cdn.ampproject.org for all publishers. And if we were allowed to set cookies on it, we could leak private information from one publisher to the next. This cookie is maintained by the AMP library, and it's just like a randomized number, and it lives for about a year. So the second way to get data from AMP is through AMP Analytics tag. And they have about 27, I think, built-in vendor configurations. MPulse is one of them. There's also Google Analytics, ComScore, Parsley, and a lot more. And AMP Analytics with built-in vendors is extremely easy to use. You simply add the AMP Analytics tag, the name of the vendor, and probably like an API key, and that's it. The predefined list of metrics that this vendor has defined is sent back to their servers for processing. It's available as an extension, and what does an extension mean? An extension is just simply an extra JavaScript script tag that you include in the page that points to a part of the JavaScript library in AMP. If you don't want to use a built-in vendor, you can certainly do it yourself. You can use AMP Analytics with a customized configuration. It's a bit harder to do yourself, but it's certainly doable. You can send the data back to your own servers. It uses the same variable substitution that we saw with AMP Pixel. The big difference with AMP Pixel is that you can use GET or a POST request, and you can configure when the beacons are being sent. And these are called trigger events. There's a lot of trigger events. The most notable is on page visible. You can also do it on page hidden, or you can do it on an AMP element when it comes visible, either as a percentage of how much of the element is in the viewport or how much time the element has spent in the viewport. And this is really useful for advertising tracking. You can tell how much a user has seen part of, or at least part of the ad, and track it that way. You can have click events where that if you have like a Facebook like button or a share button, you can beacon when the user pressed on one of these buttons. There's scroll event timers, so you can beacon and track the scroll depth of a page. There's also a timer, like an interval beacon, so you can set it up, say beacon every second, and capture this engagement time over time. So what we're really interested with the RUM performance data is the navigation timing API information. So we made a contribution to have this nav timing variable substitution, and where that you can capture any metric you want from this massive set of metrics. If you specify one metric, you'll get a Unix timestamp. If you specify two of them, you'll get the delta between them. So here's a very short example of a config that you can use to send data back to your own server. You can see in the request section of the JSON, we set up the URL that the beacon is going to be sent to. With some variable substitutions, we're sending back the URL as long as like a load time, and the trigger defines when it's going to be sent. What's important here is the on variable, and it's going to be sent on visible. So we'd like to do a live demo with you today. If you can all try to hit this link with either your laptop or your phone, and we'll see if the Wi-Fi holds up. So what we're doing is we took the site called ampbyexample.com, cloned it, we added our own analytics tag just to show how it works, and we're sending all the RUM data back to ourselves. So we're using a little Node.js server to receive the beacon with a lot of the RUM timing in it, and that Node server is then forwarding the data to InfluxDB, where it's going to capture the time series information, and then we're using Grafana to view this data. So here's an example of what you should be seeing if you went to the link. We'll show the link again in a sec, but this is, I want to show you the console. So here's an example of the beacon we just sent out by hitting the page, and you can see we've captured all the RUM timing we wanted, all Unix timestamps, and the URL should be in there as well somewhere. There we go. All that is using variable substitutions. Thank you for hitting the page. So here we can see data coming in. This is being refreshed every 5 seconds. So if you're surfing around the site, we'll see it show up pretty much immediately. We're capturing all the run timing on the top here, showing the 95th percentile. What's it at? Like 15 seconds or something. It's running on the EC2 Tiny. That's probably why. It's pretty slow. But you see hits per second, front end versus back end time. So all this is probably half an hour of work, and we're going to be sharing the code in GitHub to do this.
That works, so we don't have to use
The backup.
Okay, so we looked at how you can send your own data to yourself, right? How you could actually capture this data, or you could send it to a vendor like Impulse or Google Analytics or something like this. But let's actually look at real-world data that we're seeing. So SOSA now supports AMP data being sent to it. We're capturing it for some of our customers. We get everything from where they are in the world, all the navigation timing data that you would expect, page groups, all the kind of stuff that you would expect from RUM data. We're actually going to take a look at one of our customers that has an AMP-enabled website. So this is a news website with a blog or articles. It's about 30 days worth of data. And what we're really doing is we're comparing thousands of articles that have both a regular page and an AMP version of the same page, and just those two data sets. So we're not looking at like the home page or anything else like that. We're only comparing a page that has an AMP version and a non-AMP version. And this is kind of a breakdown of what those pages would look like too. So very similar to what we saw kind of with the BuzzFeed pages. The regular site issues 350 requests, 3 megs worth of data, and takes about 35 seconds to load on a mobile device. The AMP page, AMP optimized site, on the other hand, 19 requests, 250K worth of data, and only 3.6 seconds to load. You know, why is the regular site so much bigger? Well, it has interactive navigations. You know, the nav bar on top is very interactive, a lot of JavaScript handling it. It has very high resolution images, full screen desktop resolution images. It has a lot of other content links, so after you view the article, it's suggesting other things that you may want to look at as well, with images for those. And frankly, third-party content's most of this waterfall. I'd say over half the stuff here is third-party content. You compare that to the AMP version of the exact same page, same text. You still see the header for the site, you still see a simple navigation, but it's not as interactive as the regular site. You see article text, and you see the images that you have on the desktop version, but they're scaled down to the appropriate size and a lot smaller. And the biggest thing is there's no third parties in this one site that we're looking at. So if you're looking at a content breakdown by bytes, for the regular website, images really dominate how many bytes are being fetched to show the page. Over 60% essentially of the site's images. 25% is JavaScript. Interestingly, on the AMP page, that skews quite a bit. So because we're looking at a much smaller image, the actual bytes being sent for that image is only about 30%. And you actually see JavaScript being the biggest content size on the AMP page. Now that's not third-party JavaScript, that's not even embedded JavaScript, that's actually just the AMP project itself. We're only downloading 250K worth of data, so the AMP JavaScript itself is actually taking a big chunk of that. So let's look at the real data that we're collecting. Just to set some kind of basis for what type of visitors are visiting these two different sites. The regular site gets a lot of Chrome and IE traffic, mobile Safari, Firefox, all the browsers that you would expect. The AMP site is mostly Chrome, a little mobile Safari. We actually don't see any IE traffic. We don't know if IE is just, IE mobile specifically, is just not being directed to AMP content, or if it's so minuscule it just doesn't show up in our charts. And you see that too with what type of OS, what type of devices are loading the AMP pages versus the regular page. The regular page is about 50% Windows, 0% on the AMP site, and Android OS basically dominates who's looking at the AMP content. So let's get to the interesting stuff. Page load times. How long does it take to load each? We see the AMP site's about 3.8 times faster than the regular site. So from 4.8 seconds for the regular site down to less than a second, median times. AMP's a lot faster. So much less content. You can download so much faster, right? Pretty much expected. And that's for all visitors to the site. So both desktop and mobile visitors to the regular site and all to the other site, although that's in practice only mobile visitors. If we look at just mobile visitors to the regular site, so basically what AMP is targeting, the core audience that you want AMP to improve on, we actually see that it's even larger improvement. So mobile visitors to the regular website are taking over 6.2 seconds, and the AMP pages are about 5.7 times faster to load. Much better user experience. If we break this down into DNS times, TCP times, and stuff like that, we find a couple interesting things. We're looking at median times here. So often we actually see a 0 essentially median DNS lookup time. We think most browsers and apps that are looking at this content are probably speculatively already doing their DNS fetches before the user is going to them, so we actually don't see much time being spent looking up the domains. Interesting thing here, the regular website is still seeing some TCP connect times, SSL times. Looks like about 65 milliseconds total, while the median time for AMP content is 0. We believe this is because in many cases, the AMP content is actually being prefetched, pre-rendered. We're actually connecting to the server before the user's looking at it. Often like at the carousel of the news results or within your app, Chrome is prefetching, pre-rendering this content, so by the time the user navigates to it, there's no connection that needs to be done, no SSL handshake. So one of the biggest benefits to AMP is the presentation layer right now, which is the pages are actually getting pre-rendered a lot of the time. And so the overall response time goes down from about 404 milliseconds to 316 milliseconds. A lot of that is just from the pre-rendering benefit that you get. Now, if we take out the pre-rendering, if we were only looking at actual times where the user connected, they had to connect via TCP, they had to do DNS lookups, that kind of stuff, we actually see kind of a different story. AMP, in this case, this one customer, to be clear, it's taking a lot longer time to do all these. A lot longer DNS, a lot longer TCP and SSL handshakes and everything. Looking at it, it's actually because of the actual website in this case. The website's a very geo-targeted website. It's not US-centric. They actually have data centers very close to their customers. And so if you were to ping both the regular website and the AMP CDNs, the ping to the regular website's probably in the, from where these customers would be loading the page, is probably under 10 milliseconds, where the AMP CDN today is over like 40 milliseconds or so away. So for this one site, today in time, we actually found cases where the CDN, if you had to connect to it, would actually be slower than connecting to the customer's data center. But that's okay, because we still find that overall, the page load time is better. In fact, we looked at, so with AMP content, you can either load the page from the AMP CDN, or you can load it from the origin, where you actually put your content. We found in over 99% of cases, the AMP content was being served from the CDN. Google basically almost always sends you there. And in fact, we think the other 1% of the time is like us loading it, or other developers loading it, or bots crawling the traffic on the non-CDN. So we don't think that much, if any, traffic should be loaded from your own origin at all. Now, excuse me. Now, comparing those cases, this is looking at AMP traffic itself. If just the AMP traffic is being loaded from your origin versus the CDN, you actually do see the CDN overall provides a better load time, even with those cases where the data center is actually closer than the AMP CDN. We think a lot of the times this is the case because on your origin, you're probably more likely to be serving up dynamic content that your servers actually have to process and put out there. Whereas the AMP CDN by itself is a static cache. It doesn't need to do any calculations. It can just immediately send the content back to the user. So we see in between these two, between the AMP CDN and your origin, for this customer, it was about 13% faster to be serving it up from the CDN, which is also offloading your bandwidth for you for free. Now, how does this correlate to business metrics, right? So session length, how many pages the user is looking at on your site? Well, for this customer, we found the average session length was about 2.9 pages and for the regular website, but AMP was only 1.4. So about 48% less pages. This could be kind of disappointing, right? Looking at these numbers. We think this is for a couple different reasons. One of them is a lot of times the AMP content is being displayed. It's being displayed in something like a carousel, highlighted news articles, that kind of thing. And the visitor is going through it, and maybe they're just looking at your article, reading it really quickly, going to the next article. Maybe it's a different site, something like that. So they're not necessarily, in this case, focused and engaged on diving into the rest of the site's content. There was also another difference with how this site compared their, or built their AMP page versus the regular page, where their AMP page didn't put as many related article links in the bottom, as many links to other content within their own site. So it's always good when you're looking at your RUM data to see the differences in this, and maybe you would want to, at this point, go look at your AMP pages and see why they're not engaging as much. And in fact, if you look at the actual bounce rate, so how often visitors will only go to one page and then leave, the regular page only had a bounce rate of about 58%. AMP was much higher than that. So most people looking at these AMP articles are only looking at one article. We also found that only 3% of visitors transitioned from looking at an AMP page to the regular page. So visitors that are viewing AMP content are rarely actually going to the real site. This is by IP address, over 30 days. Now, one interesting thing that we found when looking at the referrer data for how people are coming to look at this AMP content. For this site, we found that the Google Play Newsstand app, so you can get that on your Android or iOS phones, was sending about 62% of traffic was coming from there. The Newsstand app will send visitors to your AMP pages if you opt into it, I think. But it seems to be sending a lot of traffic to this one site. And obviously the other big referrers there are Google as well, news.google and www. And we just had a bunch of unknown referrers get stripped all the time. This is a screenshot of the Play Newsstand app. It doesn't actually, in this app, it doesn't actually say whether it's AMP or not, whereas some of the other older Google apps would actually give the little AMP icon. So we have a couple conclusions. Again, we're just looking at one website's data. We want to get more. We want to continue looking into this data. We're kind of in the early stages of looking at it, right? But we think, in this case, AMP is kind of a forcing function for doing best practices. It's also a good way to get rid of your third-party content. Maybe your marketing team isn't going to be too excited about that. But a lot of the pages that we're looking at, there's just so much less, third-party downloading another third-party, downloading another third-party crap. So it could be good for you. But we also think that you could get the same performance of AMP just by hand tuning it too, right? Like AMP is best practices that you can apply on your own. You can do all these same things or even better. I think BuzzFeed is actually doing a mobile tuned version of their website and trying to put a lot of their energy into that. And I believe that they're going to be even better than the AMP pages. You can use the Google CDN or the AMP CDN to give you a free performance boost, to offload some of your content. And AMP does have some SEO benefits, but as we saw with the data, you got to be really careful about it too, because some of your users may not be as engaged going to your AMP pages versus your regular website. So are there downsides to AMP? Yeah, I mean you gotta understand it. You gotta dedicate technical resources to it. You gotta maintain it. It's a whole separate view. It's easy to have validation errors, and your AMP content suddenly isn't working. So you have to have people that understand it. We think hand tuning in many cases could be just as good. Tim has a similar proposal for the content performance policy that he's working on with some other people to kind of, it's kind of a similar way of thinking about AMP stuff, but with a slightly different focus. So if you're interested in that, please take a look at the article. And there's other competing ways of doing this, such as Facebook instant articles, but you can't actually get the analytics out of that we can out of AMP pages. So that's why AMP pages are great for this. You want to talk about some of the stuff we're working on in the future?
Sure. So these are some of the RUM features that we'd like to see implemented. First one is resource timing. We started actually a pull request about this, and we're getting great feedback. We just need to continue working on it to finish it up, and it should be great to have. And we'd be able to look at how big the resource sizes are, compare images on AMP versus your mobile, and see if the AMP CDN is actually reducing the size of some of your images, and maybe this is stuff that you should be doing on your regular site as well. User timing, I think Multi added that this week. Some of the AMP internals are tracked now with user timing, and we'd like to get some of this data in RUM. We'd also like to, instead of having beacons being triggered, we'd like to trigger user timing marks and then be able to beacon them as groups. We'd also like to know how long a page was in pre-render mode and get some information about that, because navigation timing tells you how long the page took to get constructed. It doesn't exactly give you an indication of when the page was presented to the user. So we'd like to have like a pre-rendered time.
Yeah, so that's what we got today.
Thank you.
We do have a couple minutes for questions. If you guys would want to go get drinks, that's fine as well. We can always take questions down here by the stage. So.
Have you seen anybody like just fully switch over to AMP?
The question was, have we seen anybody, just have basically only an AMP page? I haven't seen that personally. I'd be a little hesitant to do that with just some of the business metrics that we saw, but you could certainly try to do it and let us know. Simon? The question is there any ability within AMP Analytics today to know whether or not the AMP or the page has been pre-rendered at all? I don't believe there is yet.
We don't think so. That's why it's something that we want to implement or propose to be implemented.
Because that would certainly modify the performance characteristics of what you're doing and whether it's swapped in or actually having to be rendered for the user. Yeah.
Do you have any metrics on the engagement rate from search results as a result of AMP versus non-AMP? Do you have a higher click-through rate from AMP?
So the question is, do we have any metrics on engagement rate? And are you saying from a search result page, would an AMP article be more likely to be clicked on? We don't have that data, I don't think, from RUM. I'd be interested to figure out how we could do that. Maybe if Google would let us see their data, that'd be nice. Sorry, I couldn't hear the first part of that. How? Oh, HTTPS. How do they compare HTTPS versus non-HTTPS? So the question was, if I will, how do HTTPS pages on the AMP CDN or not?
The AMP CDN only serves on HTTPS, whereas the origin servers have the choice, right? Since it's your servers, you can do what you want. The AMP CDN only serves over HTTPS, but they have they have H2 though, and quick, speedy. So these are performance benefits.
An example AMP site that's running today?
A lot of publishers, like almost all the publishers in the U.S.
We were looking at BuzzFeed, for example, in that article.
New York Times, Washington Post,
NPR, yeah. And you can also see if a site has an AMP version. Looking at the raw HTML, there's like a AMP rel AMP tag basically. And you can see if they have an AMP version of the page that you're looking at. Oh, sorry, one guy over here.
It's not something we've looked at because, sorry. Are we seeing the same type of engagement with Facebook Instant Articles? The answer is we haven't really looked into it because currently the Facebook Instant Articles doesn't allow for any RUM data to be collected. The analytics portion where you're allowed to inject code is a sandbox iframe. So it's out of our scope, unfortunately.
So we'll take any more questions you guys have afterward here, otherwise go enjoy the party. Thank you.